All right, let's go back to some radian measures in pies. All right, let's look at this thing. Let's say you have 30 degrees over here. This is symmetrical. All the quadrants are symmetrical. What happens is, let's say you're trying to find the value of sine 30 or cosine 30 or tan 30, doesn't matter what the actual function is. That is going to be equivalent to, if this is 30 degrees like this, right? It's symmetrical. What's this big angle here? The small angle is 30. We know it's 180. It should add up to 180. What's the big angle?
150.
150. This 30 degree, the small angle, this is called alpha. It's the acute angle. This big angle, 150, this is denoted by theta, which is called the principal angle. What happens is, because they're symmetrical, sine of 30 is going to be equivalent to sine of 150. That's in quadrant 2. You can bring this down to quadrant 3. If this is 30 degrees here, what's your primary angle here? What's your principal angle, this big angle? Now we're 30 degrees more than 180.
210.
It'll be 210. Same thing down there in quadrant 4. If you have 30 degrees here, what's going to be your reflex angle? What's going to be this giant angle? Remember that in quadrant 4, it needs to add up to 360. So if this is 30, what's this big angle? 30 plus something is 360. The big angle will be that number. It'll be 330, right? Because it needs to add up to 360. So it's equivalent to sine of 330, like that, because they're all symmetrical. Except there is one difference. It's going to be positive in some places, and it's going to be negative in some places. That's the only difference. You're going to use something called the cast rule. C down here in quadrant 4, A in quadrant 1, S in quadrant 2, and T in quadrant 3. This is called the cast rule. What does it actually mean? It means in quadrant 1, you see that A? That A represents all. Everything is positive in quadrant 1. Quadrant 2, that S stands for sine. So only sine is positive in quadrant 2. Quadrant 3, only tan is positive. Quadrant 4, only cosine is positive. Which means these ratios, quadrant 2, sine is positive, so this is good. Quadrant 1, everything is positive, so that's good as well. But now look at quadrant 3. Sine 30 is equivalent to sine 210, except only tan is positive in quadrant 3, which means this is going to be negative. Same thing in quadrant 4, only cosine is positive. So this 330 is going to be negative, like that. So this is called the cast rule, C-A-S-T, okay? Did that make sense? So this is, we're doing this with degrees. It's the same idea with radians, not much changes. So if you had, let's say this is pi over 3. Pi is 180, so pi over 3 is going to be 60 degrees. This is going to be pi over 3. It needs to add up to pi, okay? Think about it in terms of fractions. It needs to add up to 1. Right now you have 1/3. So how big is this? It'll be 2/3, or 2 pi over 3, because it needs to add up to 3 pi over 3, or 1. So sine of pi over 3 is equivalent to sine of 2 pi over 3. Same thing down here. If this is pi over 3, that's your acute angle, what is going to be your principal angle? How can we figure that out? We are pi over 3 radians away from pi, so you just add them up. You add 1/3 to 1, right? Pi over 3 plus pi. What is that? What's 1/3 plus 1? Take the common denominator like this. You get 4 pi over 3. So this principal angle here, this big one in quadrant 3 will be 4 pi over 3. Same thing in quadrant 4. If this is pi over 3, remember it needs to add up to 2 pi or 360 degrees. What would be your reflex angle here? 2 pi, take away pi over 3. Multiply this by 3 on the bottom, 3 on the top. So you get 6 pi minus pi over 3. That'll be 5 pi over 3. So your principal angle is 5 pi over 3, okay? Like that. So you have sine pi over 3. That's the exact same thing as sine of 2 pi over 3 in quadrant 2. And in quadrant 2, sine is positive. But in quadrant 3, sine is negative. So it's going to be equals to sine of 4 pi over 3 in quadrant 3, but it's going to be negative. What about in quadrant 4? Is sine positive or negative in quadrant 4? See the C? C means only cosine is positive. Sine will be negative, okay? So there you go. And they're all related. The only difference is some of them will be positive, some of them will be negative, and you can figure out these things by doing this. You can always do it in your head, but let's say related acute angle is alpha. In quadrant 2, your principal angle is going to be 180 minus alpha, or in radians, it'll be pi minus alpha. That'll give you your principal angle in quadrant 2. In quadrant 3, it'll be 180 plus alpha, or pi plus alpha. In quadrant 4, it'll be 360 minus alpha, or 2 pi minus alpha in radians. So that's how you can get your primary angles, principal angles, primary angles, same thing. Using this concept, let's see if we can get some of these ratios. So the question says, find the exact value. That's the thing about this. If you plug this in a calculator, it'll give you some decimal irrational number. That is not an exact value. Your exact value is going to be in terms of the special triangles. Where is 2 pi over 3? Which quadrant is 2 pi over 3 in? You have pi here. You have pi over 2 here. You have 0 and 2 pi here. You have 3 over 2 pi here. Which quadrant do you think 2 over 3 pi is in? It's more than half. Like, look at this fraction. 2 over 3 is like 0.66. It's more than half, so it's not in quadrant 1, but it's less than 1, right?
It's in 2.
It's in quadrant 2. So this is going to be our theta. That is 2 pi over 3. If that is 2 pi over 3, remember it has to add up to 1. What's going to be our acute angle here? 2 pi over 3 plus something is equals to 1 pi. 2 over 3 plus something is 1. What's this? 1/3, okay? 1/3. So this angle here will be 1/3 pi, or pi over 3, like that. So that's your acute angle. Cool?
Mm-hmm.
So sine of 2 pi over 3 is the exact same thing as sine of pi over 3. Now, is sine positive or negative in quadrant 2? This is the rule, chaos rule.
It's positive.
It's positive, so that's it. Now, pi over 3 is 60 degrees. So you need to look at your special triangle. You have 30 degrees here, which is pi over 6. You have 60 degrees over here, which is pi over 3. There's a right angle. How do we build this 30-60? We talked about it briefly yesterday. There's a little trick that you need to remember. It's that sine of 30 is 1 over 2, which means in this triangle, relative to 30 degrees, the opposite side length is 1 unit and the hypotenuse is 2 units. So 1 here, 2 here. What'll be our adjacent side of this triangle? Or how can we find it? It's a right angle triangle. We have 2 sides. You use the Pythagoras theorem, right?
Mm-hmm.
So what would it be? What is this side? If that is 2 and that is 1.
It's 1.
It's not 1. It'll be root 3. Here, let me show you. So we're missing A. This is B. And this is C. A squared plus B squared equals C squared. We're missing A. So A will be C squared minus B squared, the square root of it. So it'll be 2 squared minus 1 squared. It'll be root 3. So what is sine of pi over 3? Look at that triangle. It's the opposite over the hypotenuse. Pi over 3 is 60. What's the opposite side to 60?
Root 3.
Root 3, and the hypotenuse is 2. And there you go. That'll be the final answer. The exact value of sine 2 pi over 3 is root 3 over 2. Okay? You need to do it by hand. Some calculators do spit this out though. Like I don't know about the one that you have, but if you have like a newish calculator, it'll give you one that's capable of doing fractions or typing fractions. Will give you root 3 over 2. This could come in like a non-calculator exam where you're not allowed a calculator. You have to know how to do or play around with the quadrants, and you have to know your special triangle. Phi pi over 4. Step 1, identify the quadrant that it's in. Which quadrant is phi pi over 4? You're basically looking at that fraction of 5 over 4. If it's less than half, it'll be in quadrant 1. If it's between half and 1, quadrant 2. Between 1 and 1
It's in 3.
it's in 3, right? So this is going to be your principal angle, phi pi over 4. What is going to be your acute angle? In other words, how far is phi pi over 4 from pi? You just subtract them. Think about it. How far is 5 over 4 from 1? In other words, 1 over 4, exactly. So it's going to be pi over 4. So your acute angle there is going to be pi over 4. So cosine of phi pi over 4 is the exact same thing as cosine of pi over 4. Now, let's see if it's positive or negative. CAST. Is cosine positive or negative in quadrant 3?
It's negative.
It's negative, so you'll put a negative sign here. Now, cosine of pi over 4, we can get this from the 45-45 special triangle. So you have 45 up here, which is pi over 4. And it's an isosceles triangle. You have 45 down there, which is also pi over 4. This is 1 unit, this is 1 unit. What's the hypotenuse of this triangle? It's a right angle triangle.
It's root 2.
It's root 2, exactly. So what's cosine of pi over 4? Look at that triangle. What's cosine of it's adjacent over the hypotenuse.
1 over root 2.
1 over root 2, and you're done with a negative sign. And that's the end of this question. They're all very similar. Like if you know how to do one of them, you can do all of these guys. 11 pi over 6. Which quadrant are we looking at? Is it more than 1.5 or less than 1.5?
More than.
More than, right? Is it less than 2? Yes, it is. So you're looking at quadrant 4. This angle here, this big angle is 11 pi over 6. It needs to add up to 2. What's going to be our acute angle? In other words, what can we add to 11 pi over 6 to get 2, which is like 12 pi over 6?
1 over 6.
1 over 6. So your acute angle there is going to be pi over 6, or 1 over 6 pi. And so tan of 11 pi over 6 is the exact same thing as tan of pi over 6. Is it positive or negative in quadrant 4?
It's negative.
It's negative, right? So 30-60 triangle looks like this. This is 30 or pi over 6. This is 60. It's 1, 2, root 3. So look at that triangle. Tan is TOA. What's the ratio of tan of pi over 6? What's the opposite
1
side?
over root 3.
1 over root 3 is right, and you're done. Easy peasy. Okay, is this difficult?
No.
3 steps. Step 1, identify the quadrant. Step 2, identify your angle, acute angle, and then positive, negative, and you can get the final ratio from the special triangles. Let's do something, same thing, but slightly different. Secant. Secant is related with one of sine, cosine, or tan. Do you know which one? It's the reciprocal of one of the primary trig ratios. Secant is the reciprocal of cosine. You have cosecant, CSC, that is the reciprocal of sine. And then you have cotangent or cot, that's the reciprocal of tan. So these are called the secondary trig ratios. These are primary, sine, cos, tan, and the other guys flipped upside down are called the secondary. Not a whole lot changes though. Which quadrant is 5 pi over 3 in?
The fourth one.
The fourth one. So what's going to be our acute angle? If this big angle is 5 pi over 3, what do we need to add to this to get 2 pi? Or 6 pi over 6, you can, 6 pi over 3. We need to add something to this to get 2 pi, which is like, in terms of these denominators, it's 3.
Pi over 3.
Pi over 3 is right. So CAST. Sec of 5 pi over 3 is the exact same thing as secant of pi over 3. Now, cosine is related with secant. So in quadrant 4, secant is also positive. Cosine or secant are positive. Quadrant 2, tan and cotangent. Quadrant this one, sine and cosecant, and in quadrant 1, everything is positive. So is secant positive or negative in quadrant 4?
It's positive.
It's positive, right? So to get the ratio of secant, you need to first get the ratio of cosine, and then you need to flip it. So pi over 6, pi over 3, this is the 30-60 triangle. Opposite to 30 is 1, hypotenuse is 2, this is root 3. Think about what cosine of pi over 3 is from this triangle. What is it? Adjacent over hypotenuse is the formula for cosine.
3/2.
Root 3/2. That's for cosine. Secant is cosine flipped upside down. So we're just going to flip it. It's going to become 2/3. And there you go. That's the answer to secant. Still a word problem. So there is a leaning flagpole. All right, let's say this is our flagpole that's making an obtuse angle with the ground. Okay, so let's say this is the ground. Would our flagpole would it be tilted to the left or would it be tilted to the right if it's making an obtuse angle? You know what obtuse is? Obtuse is more than 90, less than 180.
It's gonna be going like outwards.
Yeah, it's gonna be tilted to the right, like this one, because the other one would be an acute angle. So this is what we have. What else? What have they given us? This distance here is 5 meters, which is the distance, which is the length of the flagpole. So the distance from here to here is 5 meters. Now the next sentence, if the distance from the tip of the flagpole to the ground is 3.4. So I think it's going to be this distance, 3.4. Like that, and that's going to be 90 degrees because it's directly vertically downwards. Determine the radian measure of the obtuse angle. So this is what we need to find. Alrighty. Any ideas on how to approach this? I'll give you a hint. You need to first find the acute angle. Once you have acute angle, you can do 180 minus or pi minus that to get theta. How do we find that acute angle? When the angle is missing, you need to do inverse. So this one's going to be either sine inverse, cosine inverse, or tan inverse.
It's sine inverse.
Sine inverse is right. So theta is going to be sine inverse, the opposite of 3.4 divided by 5. So on the calculator, I'm going to be in radians, sine inverse of 3.4 divided by 5. So that is theta is going to be 0.75. Nearest hundredths means 2 decimal places. All right, so now that I have my alpha, which is the acute angle, how do I get theta?
You just subtract from
From
180.
So it's asking us radians, so what do we subtract it from?
Pi.
Pi. So this is going to be pi minus 0.75. So pi minus 0.75, that'll be 2.39. And you're done. That's the radian measure. 2.39 is going to be, it's less than 3.14, which is pi, but it's more than pi over 2. Pi over 2 is like 1.57. So it's going to be in quadrant 2. And that makes sense because this is an obtuse angle. Obtuse angle is more than 90, less than 180. So this angle here being 2.39 fits into the picture. So there's a compass. The needle of a compass makes an angle of 4 radians with the line pointing east from the center. Which quadrant is 4 radians in? Think about it in terms of, not in terms of pi, but what pi actually represents. Pi is 3.14. This is the center, right? Up here you would have pi over 2, which is 1.57-ish. Over here you have pi, which is 3.14. Down there you have 3 pi over 2, which is 1.5 times 3.14. It's going to be 4 point something. Then over here you have 2 pi, which is 2 times 3.14, 6.28. So think about where 4 radians is, which quadrant?
The third one.
The third one is right. So our needle is over here somewhere. That's our needle. And this angle here is 4 radians. What else does it say? It says the tip of the needle is 4.2 centimeters below the line pointing west. So this is the line pointing west. West is left. So this line, our tip, this distance here is 4.2. And again, that's a right angled triangle. The question is, how long is the needle? Or how long is the hypotenuse of this triangle? Okay, so what's our approach here? It's going to be one of the 3 sine, cosine, tans. Here's a hint. You need to first find alpha. If this big thing is 4, what is this angle here? In other words, how far is 4 from 3.14? Or what do we need to add to 3.14 to get 4? It's 0.86. Think about it. If this big angle is 4, right? This big angle is 4. We were trying to find this angle. We're just asking ourselves, how far from 3.14 are we? So all you have to do is you do 4 minus pi or 4 minus 3.14, and you will get that acute angle. Okay?
Mm-hmm.
So that's going to be 0.86. 4 minus 3.14 is 0.86. So now we can answer this very easily. You have this triangle here. You're trying to find the hypotenuse of this triangle. You know this angle here is 0.86, and you know this side here is 4.2. How can we find the hypotenuse? Sine, cosine, or tan?
Cosine.
So relative to 0.86, is 4.2 the adjacent or the opposite?
The opposite.
Opposite, right? So it's not going to be cosine, it's going to be sine. It will be sine of that angle. So sine of 0.86 is going to be equals to 4.2 opposite divided by the hypotenuse, like that. How can we solve this for h?
You multiply by h.
Yeah, you multiply by h. So h is going to be 4.2 divided by sine of 0.86. And that's it. 4.2 divided by sine of 0.86. And that'll be 5.54 centimeters. And you are done. A clock is showing this time as exactly 3 p.m. and 25 seconds. All right, so 3 p.m. and 25. A clock has 3 components. It has a hour hand, okay, which is the shortest, which is pointed towards 3. So let's say that's 3. At 3 p.m., the minute hand, which is slightly longer than the hour hand, will be pointed towards 12. So this is the minute hand. And then it says the second hand is pointed at 25. Okay, so where's the second hand here? Which number should it be pointing at? Because I don't see a 25. What do you think?
Does it point at 5?
It does point at 5, so there you go. So second hand is pointed at 5, like that. And that's the longest. If the tip of the second hand, which is this guy here, is directly below the tip of the hour hand, it is directly below. And if the length of the second hand is 9, so we know this is 9, and it's directly below the hour hand, it's gonna be 90 degrees there. And we know, what are we trying to find? We're trying to find what is this distance here? What is the distance of x? The length of the hour hand. Okay, so we're given the hypotenuse of this triangle. We're trying to find the base of it. We're either gonna need an angle or we're gonna need another side length. We have no way of knowing what the other side length is, so you're gonna need an angle. You're gonna need this angle right here, this angle, and then you have this question. How can we find that angle? You have to use logic. You have to look at the fact that we're at 5 and you can have 12. You can go all the way to 12. So it's going to be a proportion thing. What is the angle in a circle add up to? Or in a what?
360.
360, right? So it adds up to 360. 360 is for 12 hours, right?
Mhm.
So that means 1 hour will be 360 divided by 12. 1 hour is 30 degrees. So this will be 30, this will be 30, this will be 30. We're at hour 5, so what's the angle? If each hour
150.
150 is right, so what is 150 actually in this diagram? 150 is this angle here, your principal angle. 150 is, you multiply it by pi over 180 to get to radians. So that is 5 pi over 6. So this is 180 degrees, or 150 degrees, sorry, or 5 pi over 6 in radians. If that big angle is 150, what is this small angle? Use this, the fact that you have a right angle up there. Right? I don't know if you get it. This is 90 degrees, okay? This is
So
90.
is it 60?
It's 60, yeah, that's it. And now this question is super simple. That angle there, that alpha is going to be 60, which is pi over 3. Or you can multiply it like this to get pi over 3 in radians. So now we have everything. So if you just pull that triangle out, you're trying to find this length. This is a right angle, or the right angle is on the other side. This is a right angle, and you know this is 9, and you know this is 60. So pi over 3. So sine, cosine, or tan to find that x.
Cosine?
Cosine is right. So cosine of pi over 3 is going to be equals to the adjacent, which is x, divided by 9. So our x will be cosine of pi over 3, or 9 times cosine of pi over 3. So root 3 to 1 pi over 3. What's cosine of pi over 3? Look at that triangle. It's our special triangle, 30, 60. Relative to pi over 3, what's your adjacent?
1.
1, and the hypotenuse is 2. Therefore, cosine of pi over 3 is 1 over 2. So you have 9 times 1 over 2 is x. So it's going to be 4.5 or 9 over 2. So 4.5 centimeters. Does it make sense that the hour hand is shorter than the second hand?
Yes.
Yes, it does, right? Hour hand is the shortest, minute hand is the second shortest, and the second hand is the longest hand in a clock. Let's look at this one. What are they trying to find? They're trying to find the sine, cosine, and tan ratios of angle D. So the angle D is right here. Determine the length of AB is the first question. So that's our hypotenuse. Look at triangle ACB. How do we find the hypotenuse? Sine, cosine, or tangent? You're given this angle, pi over 6, and you're given this height is 8. How do we find the hypotenuse of that triangle? Sine, cosine, or tan?
Sine.
Sine will do it, yeah. So sine of pi over 6 is going to be equals to 8 over h. So h is going to be 8 times sine of pi over 6. So pi over 6 is here. Root 3 is here. 2 is here. 1 is here. What's sine of pi over 6? Look at this triangle.
Root 3 over 2.
Root 3 over 2. So you have 8 times root 3 over 2. 2 goes into 8 4 times. So the exact value of your hypotenuse is 4 root 3. What else does it say? It says find the sine, cosine, and tan ratios of angle D. We need to find this hypotenuse. We know this is 8. We know this is 8. How do we find the hypotenuse? We're looking at this hypotenuse now.
It's the square root of 128.
Yeah, that is right. So now we have everything. Sine of D is going to be 8 over square root of 128. Cosine of D is going to be also 8 over 128. And tan of D will be what?
Eight over 8.
Yeah, 1. And you are done. I'm not going to do transformations right now. Let's see what comes after this. Reciprocal trig functions. Yeah, look at these graphs. We're not going to get into this, but cosecant is sine flipped upside down. That's what it's going to look like. Secant and cosecant look very similar because cosine and sine look very similar. Tan is the weird one. Look at tan. Tan is the blue dotted line, and cotangent is the red dotted line. There's an infinite number of asymptotes when you're trying to graph tan. I'm trying to get ungraphing questions, which is it's going to come up right now. All right, let's start with. All right, let's start here. Compound angle, yeah, that's what I was looking for. Now it says determine the exact value of cosine 15. If you plug it in a calculator, it's not going to give you the exact value. Actually, let me try, because I can do fractions. Cosine 15, nope, because I'm not in degrees. Let's try that again. Cosine of 15. Actually, it does give me the exact value. But usually a question like this would come in a test where you can't use your calculator. Now we have 30. We know the exact values of 30, 45, and 60. We can get these using the special triangles, right? How can we write 15 in terms of these guys? Using two of those, right? 30, 45, and 60, we can write 15. What if I did this? Cosine of 15. If I did cosine of 60 minus 45, would that be true?
It would.
Yeah, it would be true, right? Now, why are we writing it like this? It's because we know the value of 60 and we know the exact value of 45. That's why you have to write 15 in terms of those two. Now, there's some formulas, and they're always super fun. They're giving it to us here. I can give it to you. Cosine of A minus B becomes cosine A times cosine B plus sine A times sine B. This is the formula for cosine of A minus B. So if you use that formula to open this bracket over here, what do we get? A is 60, B is 45, okay? I'm just gonna follow that formula. Look at this. It's gonna become cosine of 60 times cosine of 45 plus what?
Sine of 60
Yeah,
times sine of 45.
sine of 60 times sine of 45. And why are we doing like this? Because we know the exact value of all of them. So for 45, we know it's gonna be 1, 1, root 2. For 30, 60, we know it's gonna be 1, 2, root 3. Look at these triangles. What's the value of cosine 60? You're looking at this triangle here. Cosine 60. Cosine is the adjacent over the hypotenuse.
Root 3 over 2.
Cosine of 60 would be 1 over 2. Sine of 60 would be root 3 over 2, right? 60, the adjacent is 1. So it'll be 1 over 2. Times cosine of 45 is going to be 1 over root 2. What's sine of 60?
Root 3 over 2.
Yeah, root 3 over 2. And sine of 45 is still 1 over root 2. 1 times 1 is 1. 2 times root 2 is 2 root 2. Plus root 3 times 1 is root 3. And you also have the same denominator. So the final answer is going to be this. This value right here is the exact value of cosine 15. And this formula that we use is called a compound angle formula, where you're allowed to write an angle in terms of two other angles that you know, and then you split them up, okay?
Mm-hmm.
It's all about these two special triangles that we have on the bottom right and using the right formula. Let's look at B, tan of 5 pi over 12. That's going to be slightly more difficult. Tan of negative 5 pi over 12. What is 5 pi over 12? It's 75 degrees. It's negative 75 degrees. How can we write negative 75 in terms of these guys? Or is it even possible? Negative 75. We don't like negative angles, okay?
Mhm.
So what we do is we go to the next period. Basically, if you have something over here, if you go a whole loop, you're going to end up down there. For sine and cosine, we would add 360 or 2 pi to get to the next positive angle. Tan is slightly different. Instead of adding 360, you add 180 for tan because tan is slightly thinner. Its period is half of cosine and sine. So I don't like the negative angle. I'm gonna add pi to this because pi is its period. You can add 2 pi to it, you can add 10 pi to it, but I'm gonna add pi to it because I want to work with a positive angle, okay?
Mhm.
So the period of tan is pi. If you want to loop tan, you need to add pi's. If you want to loop sine and cosine, you need to add 2 pi's. So pi minus 5 over 12, or 1 minus 5 over 12. You know how to do fractions. That is going to be 7 pi over 12, which is 105 degrees. How can we write 105 using these guys? Can we add any two together to get 105?
60 and 45.
Right, 60 and 45. So now this becomes tan of 60. 60 is pi over 3. And 45 is pi over 4. Like that. So if we have rewritten 105, or 7 pi over 12, as a sum of 60 and 45, okay? Because why these two? Because we can get these two using the triangles over there. Now the formula for tan is slightly different. So what do we have? We have tan A plus B. These will usually be given. I'm going to give it to you every single time. So we have this, tan of A plus B. The formula for this is tan A times tan B all over 1 minus tan A times tan B. I think there's a plus here. Let me just double check. I'm doing the plus, yeah. Yeah, this is a formula, which is what I had, yeah. So this will usually be given. We're going to use this. There's a bunch of these. Look at this. There's like, what, 6 of these? And then there's more when we get into double angles. These are called compound angles. Alrighty, so using that formula, how can we rewrite tan pi over 3 plus pi over 4? A is pi over 3, right?
Mhm.
So it becomes tan of pi over 3 plus tan of pi over 4 all over 1 minus tan A. So 1 minus tan of pi over 3. I'm just following the formula. And then pi over 4. So tan of pi over 4. Like that. Pi over 3 is 60, okay? Pi over 3 is 60. Pi over 6 is 30. And 45s are pi over 4. Look at these two triangles. What's the value of tan pi over 3?
Root 3 over 1.
Right, so it's going to be root 3. What's the value of tan pi over 4?
It's 1.
It's 1, yeah. And then on the bottom, you have 1 over tan pi over 3. Tan pi over 3 was root 3 over 1, or just a root 3. And then that guy was a 1. And there you go. That's going to be the final answer. I mean, multiplying by 1 doesn't make a difference, so you can ignore that. This thing right here is the exact value of tan of negative 75 degrees, or tan of negative 5 pi over 12, okay?
Mm-hmm.
You can also work backwards. So far, we had the angle. We're going forwards, but you can go backwards, which we'll see in this next question. Question 1, it says rewrite the expression as a single trig ratio. Sine A cos 2A, cos A sine 2A. Which formula are we looking at? There's 6 down there. Which one of this has sine, cosine, and then cosine sine pattern with a plus in the middle? It's going to be the first addition formula. Look at this. It's this one. This is what they've given us. The question has given us this, and it's asking us to go back into this using the first formula here, this one. So for A, what do you think it becomes? We just add them up, okay? Look at this. It's going to
Mm-hmm.
become sine of the first thing there, first angle, which is A, and then the second angle there, which is B. Because right now, this is our A is A, but our B is 2A. So we have sine A cosine B and cosine A sine B, right? So if you work backwards, it's going to be sine A plus B. So for us, it's going to become sine A plus 2A. It's going to become sine of 3A, and you're done. What about the next question? Question B. Which formula are we looking at? Look at the pattern. It's cosine, cosine minus sine, sine.
It's
Cosine
the second one on
is,
subtraction formula.
yeah, it's this one. So if you work backwards, what does it become? Is it going to become 4x minus 3x or 4x plus 3x?
Minus.
So if you look at the pattern, if there's a minus here, right, there's going to be a plus there. So it's
Mm-hmm.
actually plus. Cosine is the opposite. If there's a plus here, then when you combine them, it becomes a minus. And if there's a minus, when you combine them, it becomes a plus. So it becomes cosine of 7x, and you're done. Okay?
Mm-hmm.
That's it. The next question is exactly the same. You just work backwards. So for 2a, what does it become? Tan 170 minus 110 or tan of 170 plus 110? You're using this formula.
It becomes minus.
Minus. So we have tan. So that entire expression, we can rewrite that as tan of 170 minus 110. That'll become tan of 60. And tan of 60, 30 is 1, 2. Tan of 60 is root 3, or root 3 over 1. And you are done. The next one here, we have cosine, cosine plus sine, sine. Be very careful here. This is a formula that they've given us, okay? Cosine, cosine plus sine, sine. When you combine them, it's going to become a minus. Because if you look at this, the plus here becomes a minus for cosine. So it becomes 5 pi over 12 minus pi over 12. What's 5 pi over 12 minus pi over 12?
It's 4 pi over 12.
Which is pi over 3, yeah?
Mm-hmm.
Pi over 3 is 60. Look at this triangle. What's cosine of pi over 3? It's 60 degrees. So what's the ratio?
1/2.
1/2 is right. And you are done. Easy. These ones are the trickiest questions I always find. As long as you can write it in terms of two others, you're good. But sometimes coming up with two others is more difficult. So special triangles are 30, 60, and 45. These are the angles in the special triangle. How can we rewrite 75? Using two of those.
45 plus 30.
Yeah, this one's easy. 45 plus 30. What about negative 15?
45 minus 60.
Yeah. 30 minus 45 would also work. Minus pi over 6. That's minus 30. You can look at it in terms of minus 30. How can we get minus 30?
30 minus 60.
30 minus 60. So remember, 30 is pi over 6. Minus 60 is pi over 3. So that will give you the answer to C. Pi over 12, I think, is 15. Let me just double check that. Yeah, it is. So this is pi over 6. This is pi over 3. And this is pi over 4. Pi over 12 is 15. How can we get that in terms of radian measures from those three angles?
Pi over 6 minus pi over 4.
So for D, it'll be the other way around. It's positive 15. So it'll be pi over 4 minus pi over 6.
Mm-hmm.
E, 105. That one's pretty simple. How can I get 105?
45 plus 60.
Yeah. 5 pi over 6 is slightly more complicated. So that is 150 degrees. Don't know why that's there. 150. You can't really get 150 from those three alone, right? Yeah, there's no way to get 150 from those three alone. Or is there? What if we do this? 60, yeah?
Mm-hmm.
Plus 60 is 120 plus 30. So that will do it, right? But it says a pair of, we have 3 over there, so I don't think that's a pair. There's no other way to get 150. Here's another way to get 150, but it doesn't use special triangles. It uses the angle of 180 or pi. You can do pi minus 30 will also give you 150. So it'll be pi minus pi over 6. There's no way to get 150 just from these alone, okay?
Mm-hmm.
We can get it from pi. All right, let's call it a day there.
Okay, thank you.
See ya.